If you want your music to sound punchy, clean, and intentional when it goes to vinyl, it all starts with how you prepare and deliver the master to the cutting engineer. Today what I want to do is show you my complete process, start to finish. Now in front of me I've got a 12-track album. And actually before we get started, 5-day mastering sprint and the best newsletter for working audio professionals, all in one. Join down below. Now let's get back to the juice. We're going to focus on sequencing here. Now, the first conversation I have with a client is, how many tracks and can you give me a track list? They send it over, I have a look, and I'm looking at the playback time. And you've probably heard things like around 20 minutes aside. So what I'm going to do is I'm going to give you some maths here. The maths is the radius difference of the record times the amount of lines per inch which are cut over the playback speed. So in the circumstance where you've got a 12-inch record, there's a 3-inch radius difference between the outermost portion you can cut and the innermost portion you can cut. You times that by 300 lines per minute and put it over the playback speed of 33.3, you have a potential playback time of 27 minutes. Now, that is being very presumptuous because that doesn't take into account the groove width, the groove excursion, how loud you're cutting it, and ideally 27 minutes is... There have been long records that have been cut, but it's not without compromise. So in a perfect world, yes, you can cut 27 minutes, but how soft is that cut going to be? How controlled is all that material going to be? What is going to be the trade-off in sonic fidelity in order to achieve that? And as we go through this process, you'll start to see some of those things unfold. So the first thing is you want to get an overall playback time. I'm, in a perfect world, wanting 18 minutes, 20 minutes you can push. You take into consideration the material as well. Now for this record, we've got 12 tracks. It's going to be split smack bang in the middle there. Because something we want to be considerate about are the tops and tails. We don't want any parts of the song or parts of the cut to have unnecessary, unnecessary time. Like just blank time, because that's money on vinyl. That's like valuable real estate. To just have 5 seconds of nothing when you could potentially be pushing a side length is unadvisable. So the first thing I do is I sequence everything in order, and then I'll delete any silences, but also play them back to make sure it actually sounds good. It's not too fast. So let's have a listen to this one. Once I've got all my sequencing in check, because I'm going to be using markers for this next section, what I like to do is I like to have consistent playback volume between them all. So I'm actually doing, this is something I've recently started doing, is just loudness normalizing from the first to the last track. And it's as simple as throwing them into RX. And this is a guide for me. This isn't absolutely how I operate this, but it's just a guide. So I'll take track 1, that's 18.5, and I'll just put a marker here, 18.5. Okay, and then I'll do the same for the rest of them as well. Now all the loudness markers are laid out. What I'm going to do is I'm going to find the softest track and then normalize each of the gain to the softest one, which is 18.7. So this will come down 0.2. This here will come down 2.5. Oops, there we go. This will come down 3.6. So now all of those are just gained for good consistent volume across each one. So now that's all done, I would go and audition all these and make sure that they do flow relatively well. If there's a louder track that has more energy, there's nothing wrong with giving it a little bit more juice there or dropping it down on a ballad. That said, when we do the emulation cut, that might reveal some tracks which can't be cut so loud and some others that can be due to physical limitations. And that's where gain plays a really important part in the way we set up our A and our B side for the cutting engineer. So now we've got everything set up in terms of sequence, we've got everything relatively gained from one track to the next. The next thing I like to do is build a simulation cut. Now, this I do using Simulathe. Simulathe, I was invited to beta test. It was during COVID lockdowns era by Fabian by Tokyo Dawn Labs. I wasn't super active in part of the beta testing, but it's a tool which I've used a lot for just auditioning material and preparing it for cutting engineers because it's just exceptionally good. So what we're going to do is we're going to set this up. So we're going to set up an A and a B side. So we're going to sit on the A side and just set up. Okay. Set up. I'm going to set the in point for the A side, the out quit for the A side. So the A side is 17 minutes long. We go to the B side. We set the in point for that. And then we set the out point for the B side. Okay, so the A side ends up being 17 minutes long. The B side ends up being about 20 minutes long. So now what we do is we feed all this information into the Simulathe plugin. So to do that, rather than playing it back in real time to feed it that information, we're just going to click commit and render this offline. And by doing this, it'll take maybe 1 or 2 minutes, but it'll build a 3-dimensional cut of this playback through its simulated lathe. So now it's read all that audio information. It has now created a simulated lathe of the A and the B side, which is great. And on top of that, it also gives me an indicated amount of usage on each side, on the A side, and if I just zoom out a little bit, on the B side. Now the B side's using a little bit more because it's a little bit longer. And the beautiful thing about this is we can work from the top down. So the things that make the greatest impact on the cut to the things which we might need to toggle and tweak. So the one thing which takes the most amount of room on a cut is how loud you choose to cut it, or how loud the cutting engineer chooses to cut it. So in an let's say an optimized situation, we're getting them to use cut it as loud as possible and get to maybe 85% of usage. The reason why you don't want to get that up to 100 and plus is because there's a inner radius distortion, or inner disc distortion, which happens, and as that radius gets tighter and tighter, it actually loses some fidelity on the inner groove. What that means is a lot of records tend to have softer songs on the inside groove, ballads or something acoustic without like big thumping low ends or sub. That said, we've got a lot of time here to work with. So what we're going to do is we're just getting up 4 dB and we're at about 83%. I might gain up 3 dB on this one, on the B side, and on the A side, gain up 4 dB. 5 dB. There's a lot of room here to work with on the A side, actually, and that's usually where your more better tracks are. The more hits are on the A side, especially if there's more room, they'll pump louder. Not that you want that, you want more even playback, in my opinion, but it's not uncommon to find a record where the A side's much louder than the B side. It's something I try and avoid. I try to have a nice even playback if I'm advising on sequences between the A and B side. But we first play with the gain. Now, let's say this was at 110%. I'd drop the gain down. And you're wondering, well, Nick, can't the cutting engineer drop the gain down? And it's like, yeah, the cutting engineer will adjust the gain for their lathe to get the best cut. But this is going to give us an idea of other limitations that are going to ensue. Because when we go to the A side and we go to disc stats, we've got a few things to look at here. We've got the excursion, which is, if you see this line here going left to right there, that is how far the needle moves off the center line. And that's typically because of low end, because longer waveforms, they don't oscillate as quickly and they will actually sway the cutting head out to the sides a bit more. And what you'll see here is if I go to that little marker there, which is the widest part of the groove, you can see that here. Wait one moment, let me just zoom in. If I bring that in, see how it's excurting there? It's coming in, it's coming out. And what I'll do is I'll set a threshold for the heat map to 45, and we'll see that here, okay? We'll see there, and what happens is that's the center line of the groove, that one there. And when it goes off to the side, it gets really near the adjacent cuts or the adjacent lines. If it gets too near to the other one, it risks the needle skipping during playback. So what we want to have is a consistent low end. We're not necessarily trying to mitigate this and do the cutting engineer's job, but we want to look at this heat map here. This is a heat map of the excursion from the cut of any potential areas that are excurting a lot of low end. And that typically is what will cause this to sway very far left or very far right. And if we go here, we've got any other markers. What about over here? Is there much happening around here? Let's just put it to 40. Nope, it's all happening back there. There's a few little hits which just happen to get, there's 2 hits in particular if you actually look. It's 2 very specific hits that just go gnarly. Go really gnarly. Super gnarly. What are those hits? What's the time marker for that? That's at 3 minutes and 27 seconds. 1 second. 3.27. Let's go there. Let's play that back. Let's have a listen what's happening there. It's just a chug there on the low end. Just that kick drum hitting down. Okay, interesting. Let's go back a section. Okay, let's cut that. And what we'll do is go back to the lathe. And what we're going to do is we're going to activate the high pass here. And we'll go 35. And let's play this back through, and then it'll give me a new heat map for that 37 seconds section. Okay, let's go back to disk stats. We'll go back to here. And, wait, excursion. Is it there? All right, that brought it down. So if we play that back before and after, now it's not pumping as much low end out. There's still some spots which are 46.9, which is there. That's not super bad. You don't want to be moving more than 45 micrometers left to right, but again, that's for the cutting engineer to worry about. All we're looking at here is there any exceptions to the rule, and this is relatively consistent. Even at the hottest part there's not a lot of low end in these other tracks, so I'm listening and I'm also looking at these heat maps down here, and I typically set the heat map to 45 micrometers on the excursion. For the width, you definitely don't want to be going over 100. Here it's 121, and that is happening at around 3 minutes, and I think that's the same track again. It's just wilding. Let's go back to here. What time mark is that? That's 2 minutes and 47 seconds. Something's going on a bit crazy there. Let's have a look. 2 minutes 47.
Yeah, you feel that, baby? That's that heat.
Do you hear that on the width? Do you know what that is? That's that synth part coming through. And you know what will tell me that really quickly? I bet you every time those synths hit, let's go over to here, my correlator is going to be in the negative, and that's what's causing that needle on the width to get absolutely wide. There we go.
Yeah, you feel that, baby? That's
See that? See that? It just drops down below -1. Now, the thing with this particular one is, to control that width, I've got all these other tracks which aren't exerting as much. They're not going over 100 micrometers wide. So what I'm going to do here is I'm going to use some automation. So I'm going to go here. I'm going to get the lathe width, add that into plugin automation. And what I'm going to do is I'm just going to ride this section here. Let's go Simulathe width and just bring it down just for that section where that pad is, or that stab is really super wide and out of phase.
Yeah, you feel that, baby? That's that heat. I know you feel it. Now, what we're gonna do, we're gonna vibe out to this one. Can you feel it, baby? It's getting hotter.
So it's just through that section there. We'll bring that width down and we'll play that back through.
Yeah, you feel that, baby? That's that heat. I know you feel it. Now, what we're gonna do, we're gonna vibe out to this one. Can you feel it, baby? It's getting hotter.
Beautiful. And what that's done, it's brought it down under 100, which is good. Sometimes if it's in the top end, I tend to automate the width, which is this one. Sometimes if it's a low end out of phase information, I'll use the elliptical filter here. And basically what we're going to do is we've done the excursion, which is any low end that's excessive. We've done the width, and now we're going to do the look at the velocity. Now the velocity cutting here, it's actually cutting quite fast. So velocity is basically high frequencies. And to cut high frequencies, the cutting needle has to travel a particular amount of distance left to right. So the needle's traveling in, as in the vinyl's traveling around, so it's already covering a surface as it travels the distance of the record. But in addition to that, you're adding extra distance to the travel of the cutter head by how many oscillations it has to do per second. And that's measured by a cutting engineer in centimeters per second. And anything over 35 centimeters a second, so the cutter head travels a total distance of greater than 35 centimeters each second, it will begin to overheat. It will get very heat because that's going to cause a lot of friction, and that's caused by lots of high frequencies, because higher frequencies oscillate quicker, so that means that the cutter head is traveling a greater amount of distance in centimeters per second. So here our maximum sort of velocity here that the cutter head could potentially travel is 38 centimeters a second. So we're going to do a heat map of greater than 35, and we're going to see everything down here that is greater than 35. We'll check the B side as well, and we've got quite a bit going on this first track here, right on the very top. Okay, and that it's typically the top end sort of stuff, some stuff poking out there which isn't too nice. It's typically high end information that's going to cause that. So let's zoom into that one. What's that one there? 38.1, that's at the time marker of 19 minutes and 19 seconds. 19 minutes, 19 seconds. Let's head over there. Boom. Okay. Okay, boom. Go to the waveform. Boom, 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 boom.
Giving you the green light. Giving you the green light.
Okay, typically sibilants or clicks or tambourines or hi-hats. Just going to go over here, see what frequency's going on there. So go there. Boom. Open that up. Actually, give me the full spectrum, man. Give me the full spectrum. A bit zoomed in there.
Giving you the green light.
What's going on? Show peak hole, please.
Giving you the green light.
Something happening up there, like at 16 kilohertz.
Giving you the green light.
On the light. There might be a little bit of latency there in my playback, but at around 16 kilohertz. So what I'm going to do here is, let's go back to the lathe. We'll cut that out. Oopsies, let's cut that out. Back to the lathe, we're going to add a low pass here. We're going to put it at 15, which is pretty high, and we might not need to do it for the whole track, just these little instances where it gets pretty hot. And let's play that back.
Giving you the green light.
We'll go back to the disk stats now.
Giving you the green light.
Okay, and
Giving you the green light.
what time mark is that? 1918. Let's just play these through.
Take your time, yeah. Use your mind, I'm here giving you the green light. Giving up the green light. To the side, giving up the green light. Stop until it feels right. Feels right. Addicted to the poison you're providing me at 9 to 5. Addicted to the poison. We can set the force, so bring the light if you ignite the fire. Bring the light. You're the poison in my mind. Feel the poison in my mind. Hooked on you.
So now that excursion there in this section is all sitting well below 35 centimeters a second. I would probably, if this was something I was setting off to a cutting engineer, I wouldn't have the low pass across everything. I'd do like I did with the high pass filter and just automate it for these sections where I have the trace, the velocity trace, and just manage that top end. You can do that with dynamic processors like a dynamic multiband, so only when it gets hot it compresses. But I like to look at the gain trace of the excursion, the width, the velocity, and automate each of these sections so there's a consistent amount of low end, a consistent amount of width, a consistent amount of velocity, being conscious of how this emulation sets up the tracing so you can be aware of the limitations that it could ensue on the cutting engineer. Because I'll give you some examples here. Let's go back to this side A. Okay, go back to the lathe, and we've done this automation on, I'm pretty sure we did this on the width, not on the low end. We did the automation on the width. Let's say we didn't do that. Now, the cutting engineer could technically definitely cut that record, and instead of cutting it as hot, they just cut it softer. Simple. The groove isn't going to be as hot. It's not going to take up as much space. The groove will be relatively wider in that section, but you'll have a little bit more noise introduced because it's a softer cut. What you want to do is you want to optimize the consistency in the low end, in the width, and the high end across all of them. The funny thing about this is 99.9% of the time, if the masters across from start to end are super consistent and good, the productions are pretty even in the sound design, I'm only doing 3 or 4 little changes, looking over everything in preparing this for a cutting engineer. So what we're going to do is I'm going to go to the assumption that I've went through everything right now. I'm happy with the consistency in the low end, the width, and the velocity. What's my next step? Well, my next step is I'm going to commit this. So I am going to make a commit run. With this, I'm going to have the processor active. So the processors are going to do all their automation and do their high pass and their low pass and cut everything through. I'm just going to monitor the input of the lathe. So what these processors do on the input of the lathe. I'm not going to monitor the feedback, the pickup, or any of the emulations because I don't want to add any additional processing. I just want to do my basic EQ, any of the width manipulation, and move on from there. So let's get that done. So let's commit that. So now that's been committed, my goal is to get all the files ready for the cutting engineer. This is exactly how I do it. So I'm just creating individual regions here. I end up sending the cutting engineer a full start to end for the A, a full start to end for the B side. But that's not what we're going to do straight away now. So we're just going to label all these. We're going to name these all correctly. So let's go through this. So that's A1, A2, A3. Now A denotes the side, obviously. So that's the A side 5, A side 5, yep. A side 6. Then we've got the B side, B1, B2. This might seem a bit redundant, but these files are good backup assets to have, and they make better sense if you know how you're naming them. B1, B2, B3, B4, B5, B6. Were there 7? No, there were 12 tracks all up. A1, A2, A3, A4, A5, A6. B1. Oh, whoops. That's B1. I accidentally cut that in 2 spots. B2. B3, let's keep it going. B4, 5, B6, beautiful. Those will all go out to a folder. I'll export these in a separate folder, which the cutting engineer can have access to. Let me just get this across. This will be individual masters. They will go to there, and that's just a preliminary sort of thing. If the cutting engineer needs access to an individual one, I really don't think they would, but it's always good to have these set up like this. Why? Because I can and I will. We've got everything we need there. That's a redundant file. Let's open up the software I use to assemble this all now. So now to assemble it, what we're going to do is we're going to take these A1 to here into Hoffer. And Hoffer is just really good because it just formats everything really neatly for the cutting engineer. You got your A side, you got your B side, and what I would do here is I'd put the track artist names in, Morny Maxwell, he's the album artist, and then you've put all your track titles in. Then you'd go to File, Export, all vinyl sides as audio files. And what this is going to do is if we export this now, get it to this folder here, I label it for cutting engineer. It's going to export those as a vinyl side A and a vinyl side B, which the cutting engineer will take as a fully sequenced A side and a fully sequenced B side. So that's going to give me ultimately the most important juice. This is what the cutting engineer sees. Vinyl side A, vinyl side B, and a track list. And on this track list, it says side A, total amount of time. That's the time. These are the tracks and their duration. Okay? And then side B, this is the total play time. These are the tracks and their duration. Then the cutting engineer will get that. It'll all be prepped. Typically, if there's any issues, they will flag it early. Once the cutting engineer cuts it on the acetate, it'll go into some baths and a dub plate will be made. And then what they'll do is they'll do some test pressings. That's the biggest thing. Like if they end up pressing 1,000 records all with the same defect, that's a major issue. So they do some test pressings, and Zenith Records here in Melbourne do 5 test pressings. These were sent off to me when Morning Maxwell was in New York, and I've got 5 here. And the reason why they give you not 1, but they give you 5 is because if you hear an issue on 1, and it's just on 1, it could be an anomaly, it could just be an artifact of the process. But if it is the same issue repeated in the same spot on the same side 5 times over, it is most likely a manufacturing defect. Now, what I do to audition this, I've got my record player in the back of the studio. That wires into my monitor controller here. And what I do is I audition it in line with the digital masters. So I'll play them both at the same time and swap my input and my main back and forth. I aim to listen to it entirely on its own as well, start to end. If anything is noted, guess what I have? Guess what I have? I have this little bad boy here. Where are we? Spacebar? Give me some spacebar. I have my vinyl track list here, and I can just note it here. I can go test pressing, and the cool thing is on the inside they're cut. There's little numbers on there, so I don't miss which one is which. I can just write track 2, side B, X amount time marker. There's a skip, or there's a jump, or there's a major defect which isn't present in the masters I provided. I've never had that issue, but I always check. If I'm not checking, I make sure the artist checks. If they're not checking, the cutting engineer, you can ask them to check, but ultimately, if you're authoring everything to get pressed, you always want another set of ears on it. Then it gets pressed, and then guess what happens? You end up with this beautiful, magnificent record, which good old Maxi did, and I'm really proud of this. I'm proud of a lot of the records which get pressed because there's sort of like a nice little stamp of, we did this, we made this. This was a big record we worked on, like a monolithic effort between everybody involved on it. So hats off to the team on that one. That was done ages ago though. But anyway, I hope this enlightens you to my process start to end of putting together a record for vinyl. It's, how do I put it? It's not as involved as some people make it out to, but it isn't something you can be blasé about and just send off whatever and hope for the best. It's something you have to make conscious effort and decision toward. And if I'm going to summarize this for you, it's consider playback length of each side, have consistent low end, consistent width, consistent high end is better than nothing. In a best case scenario, you've got somebody who understands the limitations of the format or is monitoring using, like, this is a really amazing tool. And there's even a free demo you can use of this to test your quote unquote masters for a cutting engineer. And you want to be really conscious of the limitations of excursion. Don't want to go over about 45 micrometers. Width, you don't want to go over about 100. I think I like to stick around 80-ish, 85 is pretty good. Velocity, you don't want to be more than 35 centimeters a second at any one stage, and that's all going to affect the way the cutting engineer can cut the record. The better you prepare this, the more consistent, the more within the limitations of a vinyl record they are, the better it's going to sound. And I hope this helps you. Until next time, take care.